We're going to start with a 5-digit number here where we don't know the units digit yet. So this is 1743N. N is the units digit. We want to figure out which units digits make this number a multiple of 2. Yeah, I know. You already know how to do this, right? You just look at the last digit and then you know if the number is a multiple of 2. But why does that work? To investigate, we're going to kind of separate off the units digit, and we're going to write this as 17,430 plus n. All we're doing here is breaking up the number into the units digit plus some multiple of 10. Multiple of 10. We can write this as 1743 times 10. But what we really care about is whether or not the number is a multiple of 2. But 10 is a multiple of 2. So we can write this, any multiple of 10, is also a multiple of 2, because I can just break the 10 into 5 times 2. And now we see what's going on. Our multiple of 10 is always a multiple of 2. So when I split up a number into a units digit plus a multiple of 10, I'm actually splitting it up into the units digit plus some multiple of 2. So if the units digit is a multiple of 2, 0, 2, 4, 6, 8, then the sum, we have a sum of 2 multiples of 2. It means the sum is a multiple of 2. But if the units digit is not a multiple of 2, say it's 3. If n is 3, then the number we get here is going to be between what we would get if n were 2 or if n were 4. That means if we put a 3 right here, the number we get is right between 2 consecutive multiples of 2. So it's not a multiple of 2. So now we have the whole story. Now we know why. If the last digit is a multiple of 2, 0, 2, 4, 6, or 8, then the number is a multiple of 2. Yeah, I know. You knew that one already, but now you know why it's true. And check this out. 10 is also a multiple of 5. So when I write the multiple of 10 plus the units digit, what I'm really doing is I'm writing a multiple of 5 plus the units digit. So we can use the same rule to tell if a number is divisible by 5. If the last digit is 0 or 5, those are the one-digit multiples of 5, then the original number is a multiple of 5. Yeah, I know. You knew that one too. All right, that's good enough. So we've taken care of 2. We've taken care of 5. Let's take a look at 4. After all, 4 is just 2 2's. So maybe we can use the same rule. We'll separate out the last digit just like we did before. 17430 plus n. And that's a multiple of 10. And 10 is... 10's not a multiple of 4. What do we do here? Well, maybe the last digit thing just doesn't work for 4. I mean, imagine n is 6. 6 is not divisible by 4, but 16 is. 26 isn't divisible by 4, but 36 is. So if 6 is the last digit, sometimes the number is divisible by 4, sometimes it's not. We can't just look at the last digit. Maybe we're stuck. I mean, we could just divide all this out and use trial and we should be able to find something clever here. Let's look back at what we did to find our rule for multiple of 2. Well, okay, to prove our rule. You already knew the rule. Our key step here was the fact that 10 is a multiple of 2. But 10 is not a multiple of 4. However, 100 is a multiple of 4. Let's get rid of this. Let's, instead of breaking it into the units digit plus some multiple of 10, let's break it into the last 2 digits and some multiple of 100. Right, so this is just like what we were doing when we were trying to figure out if a number is divisible by 2. There, we took the units digit plus some multiple of 10. Here, we're taking the final 2 digits plus some multiple of 100. Some multiple of 100 here, that's 174 times 100. And of course, 100 is a multiple of 4. That's just 25 times 4. And now we see that we have a rule for determining when a number is a multiple of 4. Our multiple of 100 is always a multiple of 4. So all that matters is whether or not the last 2 digits, the number formed by the last 2 digits, is a multiple of 4. So here we have the 2-digit number 3n, and can only be 2 or 6. It gives us 32 and 36 in order to make this sum a multiple of 4. When we look at this, we also see that we get, once again, we get another divisibility test for free. We get 25, because 100 is also a multiple of 25. So the last two digits have to form a number that's a multiple of 25 in order for the sum to be a multiple of 25. So the last two digits could be 00, 25, 50, or 75. Yeah, I know, you knew that one too. All right, so let's recap real quick. Divisibility by 2 or 5, we just look at the last digit. Divisibility by 4 or 25, we look at the last two digits of the number. How do we tell if a number is divisible by 8?